Material Requirement Planning, or we can call MRP, and the Just-in-Time, or we can call JIT, are two different approaches in planning and controlling materials. MRP focus planning on base sales forecast, while JIT concern on production taken from actual customer orders. Can these two methods solve the uncertainty demons? Hello, good evening everyone. Thanks for having me on the 10th International Conference on Operation and Supply Chain Management 2020. Let me introduce myself. I'm Pandhu Utomo Paksi with submission number 24, and I'm master student at the 10 November Institute of Technology on Department of Management Technology. And my supervisor is Miss Niniet Indah Arvitrida. Today, I would like to present about design and implementation of MRP-JIT hybrid system under demand uncertainty. With the outline for this presentation, first is introduction with the problem analysis and research objective. Second, about literature review with the related work. Third is methodology for the study. Fourth is the replenishment system design, outflow process, and renewal flow process. Fifth is interpretation of result from the study. And then the last is conclusion and feature work. First of all, I would like to tell why this study is very important. This research is a case study of plastic injection manufacture in Indonesia to explore how MRP and JIT can be employed in the hybrid design. The case study in this work is a non-repetitive make-to-order or MTO company. This industry is highly dependent on the seasonal, gender, age, and size because the manufacturer provides supplies for the high fashion brand company. In addition, this industry's performance relies on inventory to ensure the customer satisfaction as well as high productivity. The customer satisfaction depends on the product, quality, and on-time delivery. Next, supplies for outsold product are divided into two. First is the raw material, or commonly known as the plastic resins, and the second is the material dyes or the pigment. Both of these materials is a key element in the making of finished good. Pigment is a coloring materials commonly used in the plastic injection molding products, either in the form of the powder or the smudger batch. So, the study following inventory control on the material dyes itself, and how to implement of the non-repetitive make-to-order production system. Check it out. Okay, we are going to the next slide, problem analysis. A challenge found in this case is that it is difficult to minimize the non-moving stock in the manufacturer. You can see on the table, the total non-moving stock of the pigment in the last 6 years is amount to 7,900 kilograms, with total asset inventory is 165,000 US dollars. This number potential increase continuously as long as the integration among departments are not well maintained. Going to the next table, the most substantial downtime in the last 4 months, January and April 2019, it caused by a pigment lateness with a total time 28,494 minutes with a frequency 1,425 times. So, it means the research is very important from the practical perspective for the companies that have a stochastic inventory model with the unpredictable demand pattern. What actually is the objective of this study? First is a design a replenishment strategy use MRP-JIT approach for inventory process of the pigment. And the second is to determine the pigment inventory control policy. And the third is analyze the effect of the improvement system on the amount of non-moving stock and the accumulation of lateness pigment and also inventory level. This is the implication for a managerial perspective. The next slide is the literature review. In the plastic injection in the studies manufacturing industry, the needs for pigment will depend on the demands for raw materials, because if one is not available, the production process cannot be carried out. This concept can be identified as a push control system in the case leading to the MRP system. The idea MRP able to respond better are certain demand, and can change the order quantity by determining lot sizing. JIT able to minimize the inventory of goods in the process because it reduces space and cost. And Kanban is one of the tools from JIT, but use a signal that contains instruction for operation and the material flow information. So, means MRP and JIT are the best choice to be used in this study. An important component in the integration between the MRP-JIT is to design a system that makes it easier to determine the inventory. According to Poon, Chin, and Wong, 1998, it is advantageous to integrate JIT, the discipline of MRP, to close the loop between the shop floor with the medium and long-term planning process. According to Flapper et al., 1991, either of these alternatives allows JIT to operate with the MRP, because JIT operates by reducing inventory levels and the lot size to expose the problem. The following value update in the MRP database retain lot size and the safety stock. Next is the literature review for the academic perspective, research position and opportunity. You can see from 23rd journal and research before there are gaps in the MRP, JIT and Kanban system. At that point, I tried to conduct research with direct implementation in the manufacturing industry as a replenishment strategy for the inventory processes. This research also considered important from the academic perspective because it can serve as a reference for similar research. In particular, the implementation of hybrid approach MRP-JIT in a manufacturing industry that is implementing production system make to order, which is more common hybrid system in discussing the repetitive manufacturing industry with make to stock or MTS and the assemble to order ATO. The next is the methodology. There is the several works that need to be done to make this MRP-JIT process with the system Kanban are working. The data collection I use is the quantitative methods. Okay, first, we need to change the article document or validated document to be integrated or online. What is article document? Article document is the information about the products, material use, pigment composition, and also product weight. Before this article document, it was made into the paper and there was no record in the ERP system, so the calculation is doing by manually. You can see on the picture now the article document is going to the online. Next is the working orders, serve as proof of the material demand from the production to the material department. Working order is integrated with the master production scheduling or MPS system so that the calculation of material usage adjusts to the MPS. By this integrating, it can simplify the flow of process replenishment in pigment supplies. Okay, some data we need is article document, and then non-moving stock pigment data, OEE data, and then the purchase price list and MOQ, and then customer order and inventory forecasting. You can see on the pictures, first operator will request the material using the working orders and hand over to material department, and then department material proceed the request and the start to mix resins with the pigment and delivery to the machine that write on the working orders. The next slide is the replenishment system with existing flow process. It's mentioned on the picture. Incoming order from customer will be handled by PPIC to make a summary overview, and an overview with article document. It be preparation for pigment requirement and calculate with the output summary of pigment orders. Though there is a lot of calculation in here, it will be finished for 1 until 2 days after we receive the incoming orders, and we need to check if there is the stock in warehouse or not. If there is not stock, we need to create the purchase requisition or PR list and open the PO purchase order, and at this scope it will be takes 1 day until sign of top management. The process of pigment manufacture in the supplier side maybe take around 3 days, and then ship to company on the next days. The total will be more or less around 6 days until the pigment arrive. So if we can see, it will be have the potential of pigment stock out or lateness of the pigment arrival. So her safety stock is needed to meet the production requirement. Next slide is the important component in the integration between the MRP-JIT is to design system to make it easier. So first we need to calculating pigment requirement with the MRP system. The data need in calculating pigment is article document and the data will process with the customer orders. From these two data, MRP is used in the purchase pigment according to the orders from the customers to minimize the efficiency of the purchase pigment. Also determine the pigment purchase plan for the next potential order, which is called by plan data. Okay, next is the Kanban parameter used in determining the design of the Kanban card in the study is called barcode labels. The determining of the lot size for each pigment in this study is called containers. In implementing the MRP-JIT, lot sizing is very necessary to determine the number of batch. In the Kanban system, the frequency of shipment from supplier also. From the data we obtain, the safety stock function to maintain stock to meet the service level is 95%, and then the reorder point or ROP serve to keep stock always available during the lead time of pigment. And then determining of the number containers or Kanban card circulating in the field, and finally design process of the Kanban system. Okay, you can see on the picture there are three sections in the flow process replenishment system designed with the MRP-JIT. To make it short, first is the section using the MRP concept that can improve the inventory process in terms of the planning. And then the second section is the execution. In here, JIT accelerates the inventory process in terms of operational implementation in the field. And then the last section is the supplier. In this section, should have good communication between supplier and internal to have just in time of the pigment. So with this new replenishment design can lead to cost efficiency by reducing the total downtime machine and overstock in the pigment supplies. Okay, with this replenishment design, supply chain flow is more responsive and JIT main target is achieved to deal with the incoming orders. As can be seen on the slide, where orders are coming, calculation of pigment required already set up on MRP. It mentioned also for the Kanban availability, stock ready or not. And then we can going to directly preparation PR or the PO release. It will be takes on the same day as arrival order from the customer. With this process, supplier can be prepared buffer stock of the pigment according to the forecast that we already shared before, and it only takes 1 day until the replenishment the pigment containers. So the result in the shorter lead time from 6 days to only 2 days and reduce potential to stock out or the lateness arrival of pigment. Okay, we are going to the next slide is the policy. Determination of policy is needed so that the pigment inventory replenishment system can run well. Process flow is designed in such way as to make it easier for operators and the suppliers involved in this process to understand and follow direction according to the procedure. Several policies need to be made with the change in the new system with the aim of facilitating the MRP-JIT process, which allows for the flexibility, agility, and the response to conditions on the shop floor. You can see in the slide there is the 5 of the policies. And the next, as we can see on this slide, that's comparison from 2019 January until April, accumulated by pigment lateness per week is level above 1000 or average on 1781 minutes. And after implementation new system on the same month, January until April 2020, accumulated pigment lateness per week is on level below 1000 or average on 809 minutes. And on the graphics, it looks on the 2019 have a lot of fluctuation, and on 2020 is the more stable. On the next result slide, The data needs to analyze the results, namely by means of non-moving stock pigment, is the data that contains historical stock pigment for which there are no transactions each year. From this data, comparing with the last data, after this research was conducted, we can see on the OEE or overall equipment effectiveness data, after the implementation of the system, it decreased 54.55% for frequency to 592 times with a total 12,950 minutes, or its reduction 58.49% from the previous condition. And then the inventory non-moving stock is also decreased following by total asset inventory reducing around 70%. And in terms of inventory level, the average inventory quantity in the warehouse was reduction also by 53.3%. It's because the inventory level was limited by following quantity of the numbers and the Kanban containers. Okay, this is the last slide for this presentation, conclusion and the future works. From this research, it can be concluded that the MRP system is good at the planning pigment supply. And the study can reduce the loss that has implication for overstock or non-moving stock. JIT with the tool supplier Kanban is very appropriate when combined with the MRP. And the second is the future research is determine a policy to make easier for the suppliers in terms of the operation and delivery which become benchmark for the replenishment operating system. And then third, the following research plan is to optimize the function of the system and turn it into the digitalization, with the expectation to make it easier to implement the system accurately with the real-time data. The resulting of this information can connect to the several departments. Okay, thank you for your attention. I hope we can meet on the next OSCM forum. See you.